Welcome to Lesson 2. Use properties of rational exponents to simplify expressions. So we are going to continue today to use what we learned last lesson with exponents and radicals to help us to simplify expressions. Our objectives are to review properties of rational exponents and to use these properties to help us with our simplifications. Let's go ahead and review these properties. We really have essentially just three main properties. If you'll notice that this top property we add exponents, these next three we multiply, and the last one we subtract. So let's do an example for each of these. This first one is the multiplication property. If we have common bases and we're multiplying, all we do is add exponents. So for example, you're used to seeing something like this maybe, x times x squared. Well, you know that when you multiply x times x squared, you add the exponents, so you get x cubed. So that works even if you have numbers. For example, if you had 2 raised to the third power times 2 raised to the fifth power, you would have then 2 raised to the eighth power. You have 3 2's times 5 2's to give you a total of 8 2's. That is a very common one that you are very familiar with. Let's look at a couple of the other ones now. So let's get power of power, power of product, and power of fraction. Notice these all say power. And that's because anytime you take a power and you raise it to a power, you just distribute that power in as multiplication. So for example, let's look at this first one. If you have a base, and we'll call that base x, and you're raising it to some power, we'll say 2, but then you're raising the entire thing to another power, and we'll say 3, you are multiplying the exponents. So you would get x times 6, and that's how you would simplify that. 2 times 3 is 6. Let's look at the second one, power of a product. So what happens if you have 2 times x squared this time, and we're going to raise all this to the third power? Well, again, we are just distributing in this power to each of these. So we would have 2 raised to the third power. 2 has an exponent of 1, and 1 times 3 is just 3. And then we would multiply that by x raised to the sixth power. 2 times 3 is just 6. Okay, let's look at the last one, the power of a fraction. What happens if we have x over 3, and we are going to raise all this to the second power? Well, we do the exact same thing. We would take the power and distribute it to each of their exponents. Well, x has an exponent of 1 right now, so 2 times 1 is just 2. And then we would have 3 raised to the second power, which I could simplify to be 9. So this is our power rules. And these are essentially one and the same. Just distribute the exponent into the parentheses and multiply it times the other exponents. Here's our last one, division. And this is an important one because you'll see this quite often. All this one says is that you can move the numerator to the denominator or the denominator to the numerator just by changing the sign of the exponent. You're just flipping the signs. So for example, if my numerator was x cubed and my denominator was x squared, I can combine these by taking the denominator, and again, as long as the bases are the same, I can take the denominator and move it to the numerator and combine them. Now I could still move the denominator to the numerator even if the bases weren't the same, but I wouldn't be able to combine them as I'm about to do. So if I move this up, I need to change the sign of the 2 to a negative 2. And now I have nothing in my denominator, but all this is now in my numerator. What we have now is this first property, multiplication. Same base, I just add the exponents. 3 plus a negative 2 is just 1. Let's look at the alternate of that. What if I wanted to move the numerator down to the denominator? So, for example, in the same problem, we have our x cubed over x squared. I'm going to move the numerator down. Well, if I move it down, that leaves a 1 in the numerator. I still have my x squared down here, but now I'm going to multiply it by x to the negative 3. Okay, all I have to do now is add my exponents. 2 plus a negative 3 is a negative 1. I certainly can do this. However, when we are applying the properties of exponents, we try to avoid having negative exponents. So I would want to move the x to the top and change the sign to be a positive 1 and end up with the same answer that I had the first time. Let's try some examples. For these examples, we are going to use our properties, but we're going to combine it with our fractional exponents. Okay, number 1 example, we have the same base, which is 7, so we know because we're multiplying that we just add the exponents. 1/3 plus 4/3 is 5/3. So as long as we have a common denominator, we can just add the fractions. In our second example now we have division. Remember that when we have division, we can move 1 to the top or the top one to the bottom, depending on what we want to do. It makes sense to move the bottom number to the top because 1/3 is less than 2/3. So I'd rather subtract that and get a positive. So if we do that, we have 4 raised to the 2/3 power times 4. Now it's going to be raised to the negative 1/3 power. Remember, if we move this to the numerator, we change the sign. Now we just need to add the exponents. 2/3 plus a negative 1/3, or 2/3 minus 1/3, is just 1/3. Remember what this means. This means we are taking the cube root of 4, which we can't do that evenly, so we'll leave this as our simplified form. This top one, we would be taking the cube root of 7 and then raising it to the 5th power. Again, we can't do that evenly, so we'll leave that as our simplified form. In our last example, we have a power raised to a power. Remember, that just means distribute the power to this exponent and multiply. Well, when we multiply fractions, we multiply straight across. 2 times 3 is 6, and 3 times 4 is 12. In this situation, I would want to reduce my fraction, so 6/12 is 1/2. That means I would take the square root of 6, which I can't do evenly, so we would be finished. Let's go ahead and look at a few more examples. In this example, we again have a power to a power, so we have to distribute the power to each exponent. Well, 2, remember, is the same thing as 2/1, so we would just multiply straight across. 2 times 1 is 2, and 1 times 3 is 3. Now we need to take 27 to the 1/3 power, and we can actually do that. If you remember the cube root of 27, what number multiplied by itself 3 times gives us 27? It's just 3. So we can simplify our denominator to say 3. And our numerator would stay the same, x to the 2/3 power. Now you might be asking, well, why didn't we just move the 27 up and combine the exponents? The reason we didn't do that is because 27 and x are not the same base, so we would not be able to combine them. We could move it up, we just wouldn't be able to combine them. So this is our simplified form. All right, let's look at our second problem. Again, we have multiplication. When we multiply, we just add the exponents. Since we have common denominators, 5/3 plus 4/3 is just 9/3. But notice that we can reduce our fraction, so we would get x to the 3rd. In this example, the last one, we again have a power to a power rule. So all we have to do is multiply our exponents. 1 times 2 is 2, and 2 times 7 is 14, but always look to see if we can reduce our fractions. 2 goes into 14 7 times, and 2 goes into itself once. So that reduces to 1/7. All right, let's try our last 3 problems. In this problem, we have division, but notice that one of our exponents is negative. We have a negative 1/2, and we want to avoid that. So in this example, what we are going to do is we are going to move the numerator down to the denominator, and that way we can change the sign to make it positive. So that leaves us with a 1 in our numerator position, and then for our denominator, we have x to the 3/2 times x, and now it's going to be a positive 1/2 instead of negative because we are changing the sign. So all we have to do now to simplify is add our exponents. We are multiplying same bases. We just add the exponents. 3/2 plus 1/2 is 4/2. And then in order to finish the problem, I would want to reduce that fraction. 4 divided by 2 is just 2. Okay, let's look at this second problem. It's a little different. We have a radical, but remember what we've said before. It's difficult to work with radicals. So let's change this to be x to the 1/2. This is a square root because there is no index here. So now we have x to the 1/2 raised to the 1/3. It's easier now to manipulate this, to work with this. If we have a power to a power, remember our rules, we just multiply the exponents, so we get x to the 1/6. That would be difficult to do if we didn't change the radical to an exponent. Okay, here's our last problem. We have 3 to the -2. What do we do with that? We don't like negative exponents, but remember that any number is still a rational number because it's over 1. So this is actually a fraction, and we can take 3 to the -2 and we can move it to the denominator. If we do that, that leaves a 1 in the numerator, and then instead of having a -2 for an exponent, we have a +2. And then all we need to do is simplify. 3 squared, we know what that is, that's 9. So if you can simplify, always simplify. If you cannot, then you can leave it. All right, that concludes our lesson 2 on use properties of rational exponents to simplify expressions. So hopefully now you will remember the properties of rational exponents and use those to simplify expressions.